Good evening to one and all present in this QCrete webinar. It's very heartening to see a very good participation for this webinar, which is being organized by ICI in association with QCrete. The Indian Concrete Institute has always been striving to improve the concept of concrete quality in the country and bring the best quality concrete technologies together so that we can formulate a path forward for our country's road to success. Infrastructure development is possibly the most influential parameter for any country's GDP, and the role of concrete in such large scale development cannot be undermined. I think it is befitting the concept of Indian Concrete Institute that today we have an extremely knowledgeable and a person with vast experience in concrete, Engineer Suhas Dhuri, who will give us an insight into what he has learned from his experience. We are all eagerly waiting to hear from him so that all of us can take back with us a lot of information to actually improve our outlook to concrete. Sir, thank you for agreeing to give this talk.
Yes.
Now I hand over the presentation to QCrete team. We will start with the introduction to the speaker, followed by the presentation by the speaker, and end with the vote of thanks. I also wish to thank QCrete for their earnest effort in continuing this webinar and being associated with Indian Concrete Institute. Thank you once again. Welcome all.
Good evening, Mr. Suhas Dhuri sir.
Good evening. Yeah.
I'm Kaushik on behalf of QCrete, given the opportunity to introduce you, sir. And we are thankful to you that you have accepted our invitation to come and deliver the lecture on this day. And I also thank all the audience for being here, waiting to hear from one of the, I can say, gurus of concrete. My association with Suhas Dhuri sir goes to 96 when sir was working in ACC. He needs no introduction in many parts of India, especially the western part, Mumbai, Gujarat, etc. But just for formality's sake, I'm trying to introduce in a short while. Suhas Dhuri sir is a promoter and partner of eCube Concrete Consultants LLP. eCube is a prime consultant in the concrete industry. He has worked with ACC Limited for more than 25 years in various divisions like R&D, product development, ready-mix concrete. You name anything in concrete, he has worked. And he has complete experience of more than 40 years. He is a civil engineer from VGTI, prestigious institute from Mumbai. He has professional membership in ACA and ICA. A lot of training he has done in laboratory management systems as per ISO, IEC 17025, etc. And he's running continuously concrete consultancy services to Larsen & Toubro, Tata Housing, JSW, Chirag Readymix Concrete, and many other Readymix Concrete companies, and also Navi Mumbai Metro, K. Raheja Corporation, and many more. And he has been a pioneer in making high-strength concretes, starting from HPC M75 grade in many of the ACC Readymix plants in Mumbai. And he was associated with JJ Flyover. And I was fortunate to work with him on M40 concrete, which was specified by Mr. Dhuri in the project Kalamboli to Kalyan in Mumbai. one of the I can say one of the very toughest challenge, because the concrete has to be transported for 3 hours. Slump has to be good for 3 hours, and then it has to give M40. And Mr. Suhas Duri had put another condition that after that much slump retention, the strength of the concrete should be equal to the control concrete, that is without admixture, after 24 hours. That was a very tough task to satisfy him at that particular project. He was also involved in various prestigious projects, designed many high-performance concrete OPC with OPC and GGBS in many Readymix companies. He has given mixed designs to ISRO project in Sherikota, BARC, and many architectural restoration for BMC and the headquarters. And also he has done architectural restoration for David Saston Library in Mumbai. And he has done many structural investigation for IOC, BPCL, MIDC, SR Tower, Mumbai, BRC, Mumbai, Priestess Concrete, Water Reservoir, etc. And he has offered his mixed design and consultancy projects to Bharat Diamond Bores, live project at Rajkot, Gujarat, from finished concrete with PPC, ferro cement structural elements for Reliance project in Patalganga, Maharashtra. The list is very big. And he has done a lot of publications also, where he has presented a lot of papers in NCBM international seminars and many more seminars. The list is very big, and we have short time, so it will not be possible to read out all his accomplishments and achievements in this short time. And he has been he also published a lot of publications when he was working with ACC. And he also worked a lot for the technical support customer service cell for ACC. And with this short introduction, of course, I may not be able to do full justice to his profile. With the short introduction, I'm handing over to Suhas Duri sir. Welcome you, sir.
Thank you. Thanks for your introduction. Good evening to all engineers. Today's topic is basically today's requirement, and we are doing a lot of infrastructure and also high-rise building. So life of the structure is very important in this whole scenario. So the concrete has changed drastically for last say 15 to 20 years, and to handle with the various ingredients now available in the market, including local materials. So concrete, basically we are using local materials and some materials which is coming from the factory. And today a lot of other materials also available other than cement fly ash and GGBS. We have a lot of other materials which can be used effectively in the concrete and enhance their performance. So we are talking about that. Durability, what are the parameters, their testing procedures, and how to take care in the site. So some few snaps or my experience also I will share. We are working for various projects in Gujarat and Mumbai. So I'll share that also. So durability concrete is already defined given in the IS 456, which is our Bible for civil engineers. So this is says that performing satisfactorily, and also says that working environment anticipated exposure condition during its service. So whatever concrete you design or RCC structure you design at the particular environmental condition, it has to be last that life without or minimum maintenance. So that is the concrete. And concrete we can design today to have maybe 100, 200 years life using various ingredients. These are the few structures recently, maybe last 20 years, 25 years. JJ flyover we did in 1998-2000, and that is the first project where basically they are specified M75 grade concrete, and also they are specified durability parameters that time. So when I was working with ACC, we had designed this, and in 1998-2000 we are not having PC admixtures. We are having only a SNF based admixture and melamine based admixture or ligno admixtures. So we have used with SNF, and we have to do a lot of R&D. I think more than 6 months we have to struggle to get the concrete M75. The designing M75 is not a very critical, but the problem is that the batching plant located at X location and Y location we have to carry, and that is also in the very busy roads. If you see this bridge, it has gone in very busy streets in Bombay. That is called Bendi Bazaar. So that, and also there is a challenge to get the aggregates, because whatever aggregates available, you may be aware we are getting most of the aggregate from Navi Mumbai. Those are not that up to the mark, because when you are designed for M75, my target strength is more than 80, 85. So, and that level aggregates are crushing. So you have to select a proper aggregate. For that, we also took some time to go that. That is one project. Second, we have Worli Bandra Lake, where they use high volume fly ash. Then now one project is coming up. It is already around, I think 50% is over, is MTHL, Mumbai Trans Harbour Link project, where they are specified the durability requirements other than strength. This is basically a concrete going under attack, sulfates, chlorides, then carbon because of the vehicle and industrial pollution, and water, rains. So this is all are attacking on the concrete, and concrete start deteriorating. So we'll have to design a concrete such a way that it can take care of all these pollutants. So one is environment, then cover to the embedded concrete. I'll just discuss on this cover in the subsequent slides. Type of quality constituent materials is also very important. Cement content and water cement ratio, or right now we are saying water binder ratio, because we are not isolation using only OPC, we are using OPC plus plus plus. Workmanship also important, and efficient curing. All these parameters as a concrete technologist has to consider while designing your mix. So traditionally what has happened, we are only going with the compressive strength. Once the compressive strength is satisfied, your structural engineer is also very happy. My strengths are okay, then I am happy. But even your strengths are okay, the further construction process like vibrations, compaction, curing in the structure is varying. And then we are not able to achieve the durability of the structure. Those the strengths are within the required limit. The effect of quality is only on the surface. So when you are controlling the cover portion, and that is in the range of say 20 to 50 mm. So all your concrete is always depend upon your cover portion, and where we have to take care. And if you see today, most of the concrete, there's a lot of happening on the concrete. If the designs are not okay, mix proportions are not okay, selection of admixtures are not okay, you get a lot of issues in cover concrete. And once cover concrete is bad, your durability you lost. Influence of durability by controlling moment of aggressive agents from environment into the concrete, and that thickness is only maximum 50 mm in RCC. So durability RCC is basically a steel. Whatever steel will corrode and then it will start deteriorating. So our aim at good quality concrete cover should protect the steel from corrosion and ensure longer life of the structure. So whole idea about the durability goes to the protecting your cover to the concrete. That is 50 mm. If you able to manage that, your structure will have longer life. Now to determine that, lot of tests has been designed, and today we are adopting for various projects. So that we'll discuss in details. So in this important is that rate of controlling concrete deterioration. Therefore, the concrete material constitute near to the surface quality of finished concrete. So that is to improve the service life of the structure. We have to focus on the concrete materials and quality of construction both. So now we are depend upon the measurement of transportation of surface zone or cover zone of concrete. So transfer properties of those that cover say 50 mm or 20 mm or 30 mm depend upon the structural requirement and structural element. Structural engineer is specifies the cover, and if the cover is impermeable, your structure will remain for longer life. So what we are talking about: environment, design parameter, materials, workmanship, and maintenance. These are all the structures basically durability affects. So today mostly we are talking about materials. It's very difficult to cover all the parameters in one lecture. So we'll just discuss on materials and how to test the durability parameters. Thus the permeability of concrete decides durability. That is thumb rule. So impermeable concrete should last ever. So permeability is very, very important in concrete. So penetrability can be broadly defined as ease with the different agents like gas is there, liquid is there, ions are, they can move through the concrete cover, and the transport mechanism decides permeation, absorption, and conduction. Now, how to tackle this issue, permeation of absorption and conduction? The various tests are specified, and that we have to carry out on concrete when you do the mixed design. Normally, you are considering the permeability parameters for water permeability. That is well known, and we are using quite some time. We are using this test. Then it is the introduction of chloride permeability. Then there is the oxygen permeability, and sulfate permeability, and carbon dioxide permeability. All these are affecting the concrete cover, and then put it into the moving to the reinforcement, and reinforcement may start corroding. So there's a few tests which is basically popular to use in the industry, and a lot of projects they are accepted by various consultants and design structural designers, and depend upon your requirement, environmental condition, the type of structure, we can decide and adopt those tests for the particular structure. So water permeability is there, then water absorption is there, initial surface absorption test, softivity, rapid chloride penetration test. Then we have rapid chloride migration test. This is recently introduced, this MTHL project in Mumbai, Trans Harbour project, and it is very, very appropriate test where your chlorides are present. Then chloride penetration by ponding test, it is as per ASTM. Then we have sulfate resistance test, accelerated carbonation test, oxygen permeability test, and autogenous shrinkage test. This is the few tests. There's a lot of tests are specified, but these are all tests we can really conduct in the project, and we can protect our structure, increase the durability of the structure. So first is your water permeability. You can see this is earlier we are going as per DIN 1048, and then this is converted into BSEN into 12390 part 8. But now also IS has introduced in IS 516 part 2 section 1 2018. So this test is also now under as per IS code, and then also we can perform. When it was not there, we used to use DIN method, or the method is same, procedure is same. What we have to do is we have to apply a pressure, water pressure of 500 5 bar pressure for 72 hours, and water moves to the your concrete, and you split the specimen, and then we can see what is the water penetration. And then you design various binder content, everything, and go with the which is minimum specified at the project. There are no specific standard limits given. Generally, for normal work, we accept around 25 mm. Means railways earlier used to do this test for their bridges, so their limit was 25 mm. But slowly for normal around 15 to 20 mm is also very good concrete. But that depend upon the project, and then we can decide. This is the test. This is the setup. We put the specimen, put the water pressure about 72 hours, and then you split the specimen, and physically we can see the what is water penetrated. You take the which is the maximum depth, and that you report. Now, permeability of this water permeability under such a 5 bar pressure, it's to achieve we have to change various binder contents along with supplementary cementitious materials to achieve those parameters. Then you have water absorption. This is as per BS. So you cut the section, you cut the core, put into water for 30 minutes and see what is the absorption limits. It is because your all entire surface area is exposed to the water. So there is a porosity we can understand with the natural ambient pressure only you can find out, and that should not be more than 1.5 to 2%. So your aggregate also needs to be select properly too, because aggregate also will release absorb the water. So like this, you have to put into water, take the around 75 mm core and 50 mm depth, put into the water, and then you measure the water absorption. Very simple test, but very difficult to achieve the results, because all ingredients plays a role in this. It is exposed to the total water surface area. Then we have initial surface absorption test. This is basically a BS test. Now it is also 2020. It is included in also in IS code, IS 516. And then we have head of around 200 mm. Put the water and see how much water absorbed by the surface with time. So we'll know what is the surface of the concrete. This also can be done on your actual structure. If it's not possible, you take out the core and you can do it in the laboratory. So this is the setup. Now this has to be this to this has to be about 200 mm. And this is the capillary tubes. You put the water, start the wall, it will fill this cap and come to the here and start overflowing the water, and then you close this wall. Then with the whatever water absorbed by the surface, it will show on the capillary action, and that we can find out. So these are the typical results. Generally, we do in our laboratory. So these are the typical results. You can see you can measure in 10 minutes and also measure in 30 minutes. Then you can apply correction factor and the values. So this is also one of the tests, very good test, when you have to select the type of coatings on the surface. This is very appropriate test for it. Now measurement of absorption of water, softivity. It is basically water absorbed by the capillary action. So only one surface of the water is touched to the water of the specimen, and this with the time you have to take readings and see how much water has absorbed with the suction. This is called. So this is the way, this is a specimen. This is your water. Is only 1 or 2 mm above here, and with this and this we are closed. Everything is we are closed with the sealing media. And then water will absorb and you take the rate of absorption like this. This is the test what we conducted in our lab. You can see this. And we can find out your initial rate of absorption and then secondary absorption. You can find out the rate, whatever specified. There is a ASTM for this, and you can use it. And chloride permeability. This is a very popular test, and we are using regularly for when there is a chlorides or any durability issues. We can do the RCPT, rapid chloride penetration test. We can do in the take out the cubes, take the core 100 mm diameter and 50 mm. Now whatever we are discussed till today, the specimen depth is only 50 mm. So what we are initially I was talking about is cover zone. So only 50 mm we are testing it. If that gives the good results, your concrete will very good and your structure will be protected. So concrete sample to be provided rapid indication of their resistance to the chloride penetration. Suitably evaluating the materials and mixed proportions, design purpose, and also research and development. This also we are using in the projects. So these are the typical values you can see. And guidelines also given by the project. This ASTM 1202. See, this generally in this range we are working today. In JJ flyover, the value was 500. So it is very, very low. And we used to get practically, we used to get about 250, 260 coulomb value. So such a dense concrete we have to design for this. Here, only one point is very important, that when you are taking the sample, the vacuum is very important in this. You take out the sample, put it to the desiccator, put the vacuum and remove all the air. And then you flood it with water and then you subject to the current of 60 volt for 6 hours. That is a very simple test, but the condition is here is important to see your conditioning the specimen is very important in this, because you have to put a appropriate capacity of vacuum pump. If that vacuum pump is not proper, if the condition is not proper, you will not get a proper results. So that we have to see whenever you are going for witness the test or anybody is doing the test, you have to see first is this is okay, this is only a voltage, and this only the important is your vacuum. If you are able to manage the vacuum properly, then only you will get proper results. See, this is the cell specimen. I put the solutions here and apply a voltage for 60 volt for 6 hours. Now next, this is the Norway test basically, and very rigid test, because there we are applying a fixed voltage for RCPT. Here we are not giving a fixed voltage. We are depend on the capacity of that particular specimen. So initially you put the 30 volt and see how much current it draws. And they are given a table, and that basing on that table, you see how much hours I had to test the specimen. RCPT, we are doing 6 hours testing. That is the standard testing. Here, depending upon your specimen, we have to decide from 10 hours to 96 hours. So it is a non-steady state of migration experiment. It is a real test for this and is very difficult to achieve those parameters. So again, same thing, you put that voltage for that duration, whatever as per the specimen given in the table, and then you split it. Once you split it, you spray the silver chloride and you see the actual chloride movement in the specimen. That is, there we are only depend upon the Coulomb value. Here you can see really how much chlorides are penetrated. That we can see here. This is the setup specimen, setup of the specimen. This is the basically equipment that depending upon your voltage, CP 40 volt, 50, 50. So depending on your specimen, your voltage is selected. And then you can split this specimen and apply these silver nitrate, and then you can see this is the how much chlorides are penetrated. You can see here. So this physically you can measure the depth. And physically we can see how many chlorides are penetrated. So procedure is very clear on this, how to take out the specimens, how to split it. All these things are given in that particular 492 code. NT-built, and this was first introduced into MTHL project. That is the value of I think 5 into 10 raised to minus 12. Very difficult to achieve in the field. So this here you can see here. So you can see the depth you can measure here, and this is the final reading, meter square per second into 10 raised to minus 12. This is all the details are given in NT-build 492. If you are able to manage this test, your concrete will be excellent and give very high durability. Now this is a real life test. Means you are putting the actual chlorides and pond the specimen and keep for say 35 to 90 days. But it takes a lot of time. Other tests are due within 1 or 2 days after 28 days are over. But this takes at least 90 days. So you take the specimen, put your solutions, sodium chloride solutions, and keep for at least for 90 days. And then you remove this specimen, sodium chloride solution, and then you grind the specimen with the depth. And you take first 5 mm, then next 5 mm, then next 5 mm, and then you analyze chemically by chloride content. How much by the normal ambient conditions, how the chlorides are penetrated from the surface to the depth. So it's very time consuming test, but this has to be when you are working for the big project, this test and RCPT or RCMT, we have to see the correlation, because this is real test, live test, because of the ambient condition, what happens. We are not giving any external voltage or external current to this. So this is real test. You have to see the correlation, and accordingly we can select your specimen like this. You see how you can put the specimen. ASTM 1543. This is the code is already given for this, that can be used. Then you can draw the what is your control and how with the depth, how the chlorides are moved, so that we can draw on this chloride content kg per cubic meter. That we know limit is how much? 0.6 kg per cubic for normal concrete as per IS 456. This is one of the equipment they are developed for migration test of chloride diffusivity in situ. Means on the structure itself, the northern island, it is there. It is not yet what you call standardized. Means no standard is supporting this. But this is for research work we can do. When you are taking out the cubes and testing it, instead of that, we can go for this test and find out on the structure itself what is happening. It's called permit test. So those equipment are today available. So this also can be taken. This is just for information. Then sulfate resistance test is also about a year or you have to take. We have to cast the sulfate specimens, mortar specimen, immerse into sulfate solution. And then Portland cement and various blends. You can see the blends of Portland cement or pozzolana slag and hydraulic other materials. Can we use various things and see how your sulfates are tied? Sulfate is basically adding in aluminates, form calcium sulfoaluminates, and that has got capacity to expand. And you will find that there is a cracks. That's why nobody is advising that only OPC should use for sulfate environment. But when you are going for near the sea, your sulfates are there and chlorides are there. So both the tests needs to be seen. So this is the specimen. And if you see this, with the time we'll see this is the same specimen what we use for shrinkage of mortar 25-25 by 280 mm with your site. And then you can measure the length with time. There is also study we can have a prism specimen and take your ultrasonic value, because sometimes visible cracks is not possible. So you can take ultrasonic value with time, but it test itself, it takes at least a year. Then only you'll understand what is the sulfate attack on your concrete. So whatever binder you are use, same binder you are use with this to prepare the specimen and get the sulfate attack. Then carbonation depth, every phenolphthalein we are putting. Normally we take the carbonation after in the structure in NDT. When you evaluating for this, we take the specimen, cut, make chiseling, and take out one chunk and spray your phenolphthalein and see the where it is. This is all carbonated portion, white. This is a alkaline one, so that is giving a pink color. Now this test also can be accelerated test is available, where in BRE 2000 it is there. We have to put this condition of CO2, RH and temperature and put the specimens there. And those specimens we can split it and see the here. This is the arrangement for basically a accelerated carbonation test, because we have a lot of industrial pollutions, and even at the road a lot of CO2 is coming up, and that also affecting your infrastructure. So that needs to be checked. Earlier we are saying hardly our 0.5 1 mm per year, but now we are see within say 5-6 years we see 10-20 mm carbonation has taken place. So that needs also to be considered and go for a proper selection of materials on this carbonation test. Oxygen permeability similar to this. Then where the autogenous shrinkage, because since we are working for very high binder content, there is a possibility of autogenous shrinkage will come. So that also possible. There is a test given in ASTM to test that paste, whatever paste we are using, you can find out what is the autogenous content. Now, whatever we have discussed, what is the locally means what is the present status of that? See, in JJ flyover in 1998, these tests were specified. So we have first time come across in 1998 that we have to go, or concrete has to design, though it is M75. This is also to satisfy all these criteria: RCPT, ISAT, and water permeability. And that time this RCPT equipment was also not available. So since we have in R&D at ACC, we have fabricated our own equipment for this. All this equipment, 3 equipments, we have fabricated in 1996, 96, 97. And then we are implemented at site in 1998. And we are able to achieve those parameters what was specified for the project. And next to that, there's the Bandra Worli ceiling project. There also, these durability parameters are specified. And after that, because these are all within the sea only, so fluorides and sulfates water is there. So that is basically possible on this. Then Mumbai Metro. So when Mumbai Metro came, so they also decided, since these 2 examples were there, so they also decided to go with durability test for Mumbai Metro. RCPT was specified that time, and water permeability was also specified. And then Mumbai Trans Harbour project, they are also specified. They are introduced another test, that RCMT, that is rapid chloride migration test, and that also gives a very good idea. And they have to work for more than 3 to 4 months to achieve those parameters, whatever specified as per the tender condition. Now today, most of the high-rise building, they specify at least RCPT and water permeability. These 2 tests are most of the building they are specified. And most of the project you must have seen, this is also specified now. So we should be ready for all these tests and design concrete accordingly to go for a durable concrete. So these are some of the tests what we are talking about. The grade of concrete specified limiting factor is some of the cases, lack of appreciation of the factors downline the work site. So whenever we are design very good concrete, but it has to go in the structure, and structure has to perform. And also there should be a reliable laboratory should be nearby to get those tests done properly, because it's very difficult to put all the equipment in the site. So we'll have to depend upon your nearby laboratories, and they should be very comfortable with this test. So this is durability acceptance criteria. In durability handbook as published by ICI, Indian Concrete Institute, there's a very good book. Anybody is interested, they should go with this book, and they are given excellent explanation about all the tests and all international tests also included in this. And they are given some guidelines for the project. See here also they are given, see 5 into 10 raised to minus 12. So they are given the guidelines for this, because there is no specific guidelines given in IS code till today. Except for high-rise building, there is a temperature they are given. I think RCPT also they are given somewhere. But this also can be taken as a guide for this when we are making a specification for a particular project. I think South Africa documents are available. Those are excellent documents. They have done huge study on oxygen permeability, water sorptivity, and chloride conductivity. And those, if you go on Google, search this, and this data is very useful for your specifying your test, because they are extensive laboratory studies, and also you done some validation in the projects. That's why they are very important. We will not spend much time. This is from UAE, some project. So durable concrete, you have to materials, cement with minimum specified, large amount of supplementary cementitious material and microfine material to optimize the cement content. Earlier, civil engineers said more cement will have better concrete. But today I am saying it is, if you have list optimize the cement, you will get better concrete, because cement is also shrinking. So try to use low cement and achieve the more durability of concrete. So fly ash, GGBS, these are available. Now you have ultra fine fly ash, ultra fine GGBS, limestone. Now the new material also came, graphenes, carbon nanotubes, nanosilicates. These are also available. You can take the use of this SRA, wash sand, and new PCE. Now, one point I have just spent some few minutes, because now what is happening is, earlier we are measuring the concrete at the side by slump cone. But due to the credit to the admixture people, they are using all PCs, low PC, high PC, mid PC, and it's very difficult to get the slump. You always get the flow. Now, flow measurement with the slump is not appropriate. If you see the IS code also is very clear. They have specified this flow table test when there is a high flow, but this is not a self-compacting concrete. When your slump is more than 180 or 160 rather, you should go adopt this test and can maintain the flow 340 to 620 with tapping. So that is the appropriate test. So now wherever we are consultant, we are insisting all the contractors to, instead of slump cone, you can use this, because when you are using manufactured sand, lot of water demand takes place. And then we have to go with the high range water admixtures. And once you go with high range water, very difficult to get the slump. So always you get the flow. If you here also you can see very high category. Earlier same test was specified in IS 9103, which is for high workable concrete. That is for admixture code. It was there. So this is also there for IS code. And also IRC SP 70 also says similar way. When there is a very high flow, better you go with flow test, not a slump test. This is the test. See, this is. Now today, actual concrete after tapping should look like this. See the aggregates, everything is here. But you see the most of the concrete today, we can see like this. This is, I am saying, after tapping. If you do only slump cone, this will not able to identify, because most of the, or say 90%, 95% concrete, we are vibrating. And this is condition what we are getting at the vibrating level after. So all the concrete flows to the your surface, and surface only slurry is there or mortar is there, and you're getting a lot of cracks. And that is because your mixed proportioning or selection of aggregate is, see this. This is I taken actual site photos. It's not in laboratories. See this. This is really not a good concrete. Now this, whatever portion we are looking at, this concrete goes to the cover portion. And we can see the concrete cover at crack. A lot of final cracks, and that is also you have lost your durability. There is no point in repairing the cracks. Better you go for adjusting your mix proportion, selection of appropriate admixture. See, this is a good concrete after, see, cohesion is there. Now, most of the time, people are using this test as a slump flow test. But remember, slump flow test only given for self-compacting concrete, not for normal concrete. You are going for such high flow, don't. Especially we are seeing in my one. People are using this core and measuring like this. Now, this is without vibration. Once you vibrate, everything is separated out. And then your structure will affect with the durability. So this is also one of the video is there. See this, how they are doing. I don't know whether it is appropriate. See the concrete. So this awareness has to come, and then he is vibrating this. Now he is vibrating. This is not a standard test. Somebody's mind comes and they do whatever test you have to do. Always you have to find that a standard test. That's why I shown that to go with the flow test. See, this is the way of concrete today we are handling. We should avoid such concrete. Initial curing also we are missing today at the site, and then we are struggling that cube has given different result. You can have like this also. Otherwise, all the cubes are lying like this first 24 hours. See this. This is really how we are maintaining the quality. Now these maturity sensors are also there available today. We can insert into the concrete and you can take real-time strength. This is what one of the project we are done this exercise, and this is the actual concrete. This is M35 concrete. We have used only 120 kg of cement and 280 of GGBS, and we are able to achieve strength at 29 MPa in 7 days. Because of this, there is a huge raft was there. So these techniques are available today. I think we can take the advantage of that. Here, this is the sensor. Raft of 1.9 meter depth, around 3,500 cubic meter in one go. So this is again a setting time of concrete I have not discussed. See this what happens. This is already set. Now new concrete will come up, then durability has a loss. So durability to achieve concrete design, concrete production and as built structure, and client basically interested in the as built structure. So standardization is required, then your acceptance criteria and test to be carried out for this, and then capabilities of your person. Cementitious system is very important in the durability and fine aggregate proportioning. Compatibility study is very important. Now, earlier we are talking about only a cement, but now fine aggregate also, manufactured aggregate also contain lot of clays, and that also affecting the performance of your admixture. That also needs to be checked. And as I said, workability requirement, inflow, initial flow, and retention, bleeding and segregation. You have to avoid 100%. Needs to be addressed all the aspect by professionals. So that's why we need a professional to address this. Concrete has changed. Like earlier we are having a family doctor. Now for each we are going with experts, but expert doctors. Like this, concrete is also one part where we have to consult properly and get our structures durable. Thank you. Now I can open for any question is there. Hello.
Hello.
Yeah.
Thank you, sir. Now will be the question answer session. First question,
Yes.
what is deteriorating in concrete structures? Asked by Kami Shetty Nikhilesh.
What is deteriorating?
Deteriorating in concrete structures.
See, basically, your reinforcement by RCC structure we are talking about, reinforcement is corroding. Once the reinforcement is corroding, their volume changes and it reduce the section of steel, and then their loading capacity is reduced. So that is a reducing. Means basically chlorides goes into that, and chlorides are vulnerable to corrosion. And due to the corrosion, your deterioration starts.
Okay. Thank you, sir. Next question is, what is ponding test and softivity? Asked by Kami Shetty Nikhilesh.
See, ponding test is basically a long-term test with the natural conditions, ambient condition. You have to keep the uh, pond at the specimen, and with that ambient condition, concrete depend on the porosity of the concrete, it penetrate the chlorides in the concrete. So after 90 days, you remove that and slice your concrete and see with the depth how much concrete these chlorides are penetrated in this. So we are taking actual measurement of chlorides by chemical analysis. Softivity test, because of the capillary action, water is coming out to the in the concrete. So only one surface area is exposed, and from there water is sucked to the depend on the porosity of the concrete. So if you make very dense concrete, it will not suck. If you have porous concrete, it will definitely suck the water, and that rate of measurement is your softivity. You can refer to that particular
Thank you,
ASTM
sir.
which I referred. Yes.
Thank you, sir. Next question is, what about the reliability of RCPT asked by Dada Patil?
Reliability in the sense what? Because it is already proven that once you have a concrete, and if you have very good whatever norms they are given, suppose 1000 or 2000 coulombs value as given, it is really a good concrete. It is proven in the field also, because we have taken the concrete core from the structure and also tested. So it is gives the penetrability of your chlorides. That's why it is reliable test. Means I didn't get you exactly what is the question.
What about the reliability of RCPT?
No, this is, see, when it has come into the standards, it has taken lot of test, field test and laboratory research tests and their combinations, and then only it is introduced to the standard. So reliability is there.
Okay. Thank you, sir. Next question is, which constitute majorly affect the performance of concrete?
Basically, there is no single component, including your fine aggregate, including water, also affecting the performance of concrete, because this is also reacting with the materials. If you see when we are taking site mix concrete, people are using any water. That water has to be as per the requirement given in IS 456. Here in Mumbai, if you dig the water, it get all chloride water. And if you use that water in concrete, definitely that concrete will deteriorate, because reinforcement corrosion is start. And we have seen a lot of projects in Mumbai where within 3 to 4 years, concrete has started corroding. And once we analyze that concrete, we have found that 6 to 7 kg per cubic meter chlorides are there in the concrete itself. So this is sometimes water also is affecting. Aggregates are there, cement is there. Each and every ingredient is important.
Thank you, sir. Which type of concrete is used in cooling tower? Asked by Sukumar.
Where cooling tower.
Yes, sir. Which type of
Cooling?
concrete is used in cooling tower?
I think that will be by design. I think it is M35 to M40 concrete. But they are using lot of coatings over the concrete because it is always under water.
Thank you, sir. Next question is, what type of curing method is ideal in case of geopolymer concrete using fly ash or GGBS as a cementitious material? Asked by Vinay S.
But geopolymer, I don't think we required any curing. It will work in ambient condition only. No curing is required for geopolymer. It's exothermic reactions.
Okay. Thank you, sir. Next question is, what should be the frequency of durability test?
That depend upon the project, but we have to see how number of sample, number of grades and quantity, and number of structural elements. Accordingly, we can select it. There is no fixed frequency is given for durability test, not yet. That will you have to decide depend upon the structure.
Thank you, sir. Next question is how the concrete can be tested with maturity sensors.
See these maturity sensors, whatever concrete we are going to place in the structure, initially we have to cast the cubes and calibrate those probe till 7 days or 28 days and establish a correlation. Means you cast the cubes with probe and with the normal curing, whatever you are doing for water curing, and they test it and develop a curve. And that factor we can put it there in the software. Then it will give online strength of that particular concrete. It is basically concrete strength is nothing but a function of time and temperature. That is the maturity. So we are taking on one datum line, and depending upon your time, it goes up, temperature goes up. So function of time and temperature is maturity. So that has to be calibrated, and there is a ASTM code for it first. So you can just refer the code. It is detailed procedure is given, and also those people who are supplying the GTEC, they also have a procedure. But first need to be calibrated, establish the correlation, and then we can go for use in the field. So till 90 days, you get the strength on your mobile. It is a application available once it is you have taken those sensors. So you can install it, go to the nearby, maybe 1 meter near to that, and you will find that your signal is coming up. There is a wireless things are there, and that we can check on your mobile. Online, we have done up to 56 days, we have got results.
Thank you,
Yes.
sir. Next question is silos have high temperatures, so in that case, its strength remain constant or varies due to temperature effect.
I didn't get the question. Silos means what? Cement storage silo?
Yes, sir. Silos have high temperature, so in that case, its strength remain constant or varies due to temperature effect.
No, that is not contributing for your strength in the when you make the concrete. It is affecting your workability first. If you have 50-60 degree temperature of the cement, ultimately you are using ambient temperature water. So that is brought down, but then your performance of workability is reduced. So that silo temperature is nothing to do with the strength of the concrete. Once it will mix with the water and it has exposed to the higher temperature, then definitely the concrete will gain the strength early stages. That is accelerated curing what we are doing, or warm water method what you do. But temperature is also is very difficult. Means if you have very high temperature, it's not advisable to use in direct concrete immediately, because you may get flash set.
Thank you, sir. Next question is addition of fly ash increases or decreases durability? Asked by
Increases.
Kushbu Parmar.
It is increases, but depend upon which type of fly ash you are using, whether it is appropriate, properly selected fly ash. Because fly ash is also coming with various, though IS 3812 has given the parameters. The fly ash should meet those parameters, then only you can use in concrete. But
Thank you,
definitely
sir.
it improves the durability.
Thank you, sir. Next question is what is the recommended durability test for water retaining structures?
One is a water permeability, basically. Water permeability is sufficient.
Water retaining structures.
Yeah. So water permeability test is there under that pressure, no? If you are able to manage maybe 10 mm or so, it is an excellent structure.
Thank you, sir. Next question is which type of concrete used in turbine foundation? Asked by Ghanshyam Garg.
Turbine foundation, there's no specification. There is basically grade, but turbine formation is required to have a very high amplitude. So that needs to be checked, and vibrations. So that is nothing to do with the concrete design part. So they work out the accordingly and then specify the concrete.
Thank you, sir. Next question is, how does concrete structures get affected by heat?
Generally, concrete is very comfortable up to 100 and 150 degrees centigrade. Once it is crossed that, once cross around 350 degree, it start deteriorating the bond. Basically, bond is, we are losing the bond between aggregate and paste. So up to 100, 150, there is no issue. But when there is a temperature continuously more than that, then you will have an issue. It will deteriorate. Definitely, it will deteriorate. But then accordingly, we have to go for the refractory concrete. You cannot use hydraulic concrete because water is there. Water will evaporate. So that should not do. You can go by refractory concrete where the temperatures are high.
Thank you, sir. Next question is, do you think durability more important than strength of concrete, and how you manage the durability in the mix? Asked by Vinay Jadhav.
See, definitely, but if you see if you see my lecture, I'm talking about initially the strength is not the important, durability is important. Now, if you see the IS 456, the specification goes to the durability. If you able to manage those parameters, say water cement ratio is the minimum grade is there and the exposure, if you design accordingly, definitely strength will be achieved. So once you design for durability, your strength is automatically it will come, because to achieve those parameters, we are required to have water cement ratio. Then your binder content has to be slightly or more side, higher side. So once you design for durability, automatically strength will come. It will never happen that you design a concrete for durability and your strength is not achieved. You will get more strength rather.
Thank you, sir. Next question is, any special testing methods for self-healing concrete? Asked by Benjamin.
There is only microscopy is there. People are using microscope to see the self-healing concrete. So we'll have to go under microscope and see how it is healing the concrete, because by naked eye is very difficult to see. Some people are doing some put some water cube and put it, but that is a very crude method. Really, you have to go. You can go cut the section, see under microscope or SEM, scanning electron microscope, and physically we can see whether cracks are healing or not. Especially all these people who are selling your crystalline waterproofing. So those are, I mean, but in my opinion, you should go with SEM and see the real healing of concrete.
Thank you, sir. Next question is, if all durability tests are passed, then what would be the maximum life of structure? Asked by Sanjay Jadhav.
There is basically a software available. I think you must be the popular software is 360 Life 365. So in that, if you put all the parameter, you give the estimated life. Because the durability parameters, their limits are very important in this. Because when I say water permeability, my project 20 mm is sufficient. Some project I got only 5 mm requirement. So definitely 5 mm will have more life than 20 mm. So all those parameters you have to put and see estimated life of that. So 2-3 various softwares are there. If you go search on Google, it is available.
Thank you, sir. Next question is, if add the water inside, it leads to cracks and strength, what is internal effect in concrete? Asked by Veerababu Rokalla.
Now, we are not supposed to add water first. So basic mix design, you are change on this. So water cement ratio has gone there, and will definitely the porosity has increased. So your durability is also increased. So whatever extra water added in this, it is diluted the whole concept of your mix design. So definitely those properties what you are designed in laboratory or in the plant is not possible to achieve after adding water.
Thank you, sir. We have covered all questions. Next will be vote of thanks. I will handing over to Shelly, sir.
Thank you, sir. Thank you, Duri, sir.
Yes, sir.
It was a very interesting talk. The more we talk on durability, it never ends actually. And
Correct.
ground level, it is the conditions. Lot of training works is, as you said, it is required actually.
It is required.
Yeah, it is required actually, and we could very interestingly go through a lot of tests. What we had suggested actually, some of the tests which we had also heard for the first time actually. So these are the things which is going. It's a future for our concrete actually, and
Right.
since a lot of trust is coming in the infrastructure, and we have a lot of multinational companies coming to India because India is growing at a very fast rate actually, and then we feel that Indian engineers abroad are doing well, so we also have to start jacking up and taking it
Correct.
the next level actually.
You should
So
be
all
ready
the
for it.
yeah, we have to get really ready for it actually. Otherwise, we'll be outdated and we'll be thrown into the
Correct.
dumps. That's what I feel actually. So all these lectures, what we are doing, and more of the durability lectures, I can see that a lot of attendance are there, a lot of curiosity is there, and the way what he said is that a lot of engineers are getting trained, but at the ground level, at the place where the concrete is really happening, some more focus is required actually, so that
Correct.
hand in hand everybody plays for the durability of the concrete structures actually. Thank you, sir, in this contest. Thanks a lot for giving us a very good lecture on this particular topic, durability parameters, options, and starters actually. Many more lectures we are hoping that we will be in future will be able to conduct in this line actually. Thank you, sir. Thank you very much.
Thank you. Thank you for your all
Yes.
attention. Thanks.
Yes. And I thank also Indian Concrete Institute chairman and EC members of Coaching Center for associating with QCrete for successful conducting of QCrete webinar series, and also thank Kaushika for continuously pursuing this dream of achieving this 100 QCrete webinars series actually. I hope in coming months we'll be definitely having more such lectures in taking it forward actually. And I thank all the participants who had, in spite of being their busy schedules, has joined in good numbers for our QCrete webinar series. Thank you all. I am Shelly S. Fernandez, QCrete Readymix India Private Limited, signing off the QCrete webinar series. Till we meet for the next webinar. Thank you all. Thank you very much.
Okay. Thank you. Thank you all.